Assalamu alaikum. It seems that only Afnan has joined. No other students are there. Ayman joined a few minutes back. He left already. So let us begin our class, inshallah. By this time, if somebody joins, fine. If nobody joins, that is also fine. No problem at all. So today I'm going to discuss February-March 2015's paper 3-2. For each of the following, give the name of an element from period 3, sodium to argon, which matches the description. I have already given the answer. Go through this one. I have also given some sort of explanation here. So if you have any doubt, you can tell me. An element which is gaseous at room temperature and pressure, it could be chlorine. Okay, then an element that forms a basic oxide. So basic oxide, metal oxides are basic, we know that. And the type is XO. XO means the valency of oxygen, and X will be same as the valency of X is as the valency of oxygen is 2, so valency of X should also be 2. So it is a group 2 element. It could be magnesium. An element used as an inert atmosphere in lamps, argon. An element that forms an amphoteric oxide, aluminium. Okay, then an element that reacts vigorously with cold water to produce hydrogen. So sodium would be the answer, because we know that group 1 metals, we can write it down that the group 1 metals react vigorously with group 1 metals reacts vigorously with cold water. We can write that group 1 metals react with cold water vigorously. Okay, so this could be another one. Now the definition is given here. Isotopes are the atoms of the same element having same number of protons and electrons but different number of neutrons. We can proceed to the next one. Have a look at this table. So I have already completed the table. If you don't understand anything, you can tell me. Did you see? Look at B. Number of proton is 11 and number of neutron is 12. So 11 plus 12 will give you number of nuclear number 23. Okay, then proton number is the identity of the element. So this is sodium, and the difference between electron and proton tells you the number of charge. So here we are not writing mass number or atomic number, we are writing the charge. So there will be one positive charge because there is one more proton than the electron. 11, look at this 11, and here it is 10. So that is why the charge is +1. Okay. So similarly, I have given the answer for C and D. If you have any doubt, you can write me on the chat box, because chat box is also open for you. So if you want to write anything, you can write over there, no problem. See, I have filled up already. So if you have any doubt in this table, tell me. I will take 1 minute for this one. Okay, come to question number 3. Ammonia is manufactured by the Haber process. Nitrogen and hydrogen are passed over a catalyst at a temperature of 450 degrees Celsius and a pressure of 200 atmospheres. The equation for the reaction is as follows. So the forward reaction is exothermic. State 1, use of ammonia. Ammonia is used as a fertilizer. Ammonia is used to produce fertilizers. Ammonia is used to produce nitric acid. So multiple uses are there. So you can write any of these uses, right? I think it is okay, right? No problem. Then what is the meaning of the symbol? This is reversible. This is reversible. Okay. What are the sources of nitrogen and hydrogen used in Haber process? What is the source of nitrogen? You know that nitrogen is found from air. Uh, the main uh, the main element, I mean the main component found in air is nitrogen. It is 78 to 79%, whereas oxygen is 20 to 21%. So the major element of major component of air is nitrogen. So nitrogen is obtained from air or atmosphere, right? Okay, what about hydrogen? Hydrogen is obtained from the reaction of methane and steam. You can simply write methane, water, steam, alkane, anything. Okay, so nitrogen we can write from air. Nitrogen we can write from air, from atmosphere, and hydrogen from the reaction of methane and steam, or simply from methane, simply from steam, both can be written, no problem. Okay, name the catalyst in the Haber process. What is the catalyst used in Haber process? This is iron, right? Okay, if the temperature is higher than 450 degrees Celsius, you have to notice this one very carefully. If the temperature is higher than 450 degrees Celsius, higher than 450 degrees Celsius was used in the Haber process, what would happen to the rate of the reaction? Give a reason for your choice. So let us go back if you forgot by this time. This reaction is what? Exothermic. That means forward reaction is exothermic. And what is our knowledge? I'm repeating this one. Rate of the reaction. Okay, we'll be talking about yield after a while. First, let us talk about the rate of the reaction. If you increase the temperature more than 450 degrees Celsius, obviously the rate of the reaction will increase. So we can tell that the rate of the reaction will increase, right? The rate of the reaction will increase as molecules will have more kinetic energy. Molecules will have more kinetic energy. More molecules will have activation energy. So more frequent and successful solutions will occur. Okay, so this is how you can write. Next, if a temperature higher than 450 degrees Celsius was used in the process, what would happen to the yield of ammonia? Now, yield is dependent on the equilibrium, right? So, which side the equilibrium will shift if we increase the temperature? So, I'm writing the basic knowledge here first. We know that increasing temperature favors endothermic reaction. Endothermic reaction. But here our reaction is forward reaction is exothermic. So increasing temperature will move the reaction backward. Okay. So what would happen to the yield of ammonia? So we can write that yield of ammonia will decrease. Yield of ammonia will decrease as increasing temperature shifts the equilibrium to the left hand side. We can write in short left hand side because forward reaction is endothermic. Is that clear? Please respond. Please respond. If you don't respond, I cannot understand. In the chat box, you can tell. Did you understand the explanation? Let me unmute you. Okay. So, Mushran, did you understand? Okay. Fine. Thank you very much. So, let's proceed to the next one. If a pressure higher than 200 atmospheres was used in the Haber process, what would happen to the yield of ammonia? If a pressure higher than 200 atmospheres, so you need to know the relation between pressure and yield. Pressure and yield. We know that higher pressure, so I'm writing the basic knowledge first. Higher pressure favors the side with less moles, right? Higher pressure favors the side with less moles, and lower pressure favors the side with more moles, right? Opposite. So if a pressure higher than 200 atmosphere was used in the Haber process, what would happen to the yield of ammonia? Now let us check the equation once again. If you forgot by this time, so see in the left side how many moles are there? There are 4 moles, right? How many moles are there in the left side? We have 1 plus 3, 4 moles. And in the right side, how many moles are there? Only 2 moles. So in the right side we have less moles. Higher pressure will favor right hand side, right? Okay, so we can tell that higher pressure favors the forward reaction as right hand side has less moles. Okay, So yield of ammonia will increase, right? Yield of ammonia will increase. Explain why the rate of reaction would be faster if the pressure was greater than 200 atmospheres. The rate would be faster. Why the rate would be faster? Uh, because more frequent collisions will take place. Okay, so at higher pressure we can write at higher pressure molecules will be squeezed in a smaller volume and um, more frequent collisions will take place, right? Okay, so I hope this is clear. Suggest one reason why a pressure higher than 200 atmosphere is not used in the paper processor. What is the disadvantage? It is not cost effective, right? What is it? Is it cost effective? No, it is not cost effective. So suggest one reason. So as I told you that that higher cost, and another issue that you can mention about the safety. Okay, so safety issues can be mentioned as safety issues or higher cost. Okay, okay, sorry. Next, draw a dot close diagram on the paper. You draw a dot close diagram for the arrangement of outer electrons or valence electrons in one molecule of ammonia. So ammonia is NH3, you know. So write down this one. We can use this here. Uh, Nitrogen. Use nitrogen. Use nitrogen. Okay. Then let us do one thing. Let us draw a circle. Okay, I will be using instead of dot, I will be using tick. That will be easy for me. So I'll be using tick here. Okay, tick, 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 and I'll be using cross for nitrogen. So cross, 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 and there'll be two more. One is here. So this will be the structure of ammonia. Any problem? If you have any problem, you can tell me. Please respond if you understood or not. Next one. So I can erase the drawing if you don't have any problem. Okay. Now let's come to the next one. What is a base? Ammonia acts as a base when it reacts with sulfuric acid. So a base is a substance which accepts proton or hydrogen ion acceptor, right? What is a base? base, sorry, base is a proton slash H plus, etc. Right? Okay. Then the balanced equation, ammonia plus ammonium sulfate. So, so this is preferable. The first equation is preferable. Second one you can ignore. So this is the first equation: ammonia plus sulfuric acid, ammonium sulfate. This is what you can write. Oh, let's go for the next one then. A compound X contains 82 point. Okay, so look at this. Calculate the empirical formula of the compound. So you have to make a table. I have shown the calculation here: number of moles of carbon, number of moles of hydrogen. So how can you do that? The mass divided by relative atomic mass will give you number of moles. So number of moles for both are found here. Now the fact is you have to find the ratio of moles. So 6.89 is to 17.24. It is 1 is to 2.5. So we have multiplied both by 2 to get integer. So 2 is to 5. Therefore, the empirical formula is C2H5. I hope it is clear. Empirical formula is C2H5, correct? Okay. Then molecular formula is N times. So let the molecular formula be C2H5N. After that, C2H5N will be 58. What is the value of C2H5? This is 29. So 29 times N will be 58. Therefore, N is 58 by 2. 29 times N is 58. So N is 58 by 29, correct? So the answer is 2. So the molecular formula of C2H5 2 C4H10. So this is, it is not written. What is it? So can you tell me what this is? This is butane, right? 10, sorry, not understood. Okay, so let's go for the next one then. Alkenes are unsaturated hydrocarbons. State the general formula of alkenes. State the general formula of alkenes. So what is the general formula of alkenes? This is CnH2n. Okay, empirical formula of alkenes, CH2, CnH2n, right? CnH2n. So here n is 2, n is, sorry, n is 2, 3, 4, dot, like this, right? So CnH2n. This is the but what will be the empirical formula? Empirical formula for all the alkenes will be CH2. What do you mean by the term unsaturated? What do you mean? So contains the carbon-carbon double bond. Sorry, contains double bond. Or you can tell that all the bonds are not single bonds. All the bonds are not single bonds. If there are double bonds, then it is unsaturated. Okay, then what do you mean by hydrocarbon? A compound containing carbon and hydrogen, right? Okay, I hope it is clear. Did you understand? Till now, no question, right? Okay. Describe a test that would distinguish between saturated and unsaturated hydrocarbons. So, to distinguish, we know that we can use bromine water. Reagent should be bromine water. bromine water or aqueous bromine or bromine solution, bromine water we are writing. Observation, saturated hydrocarbon. So bromine water remains same. So we can write that bromine water stays same or stays brown, okay, or red brown if you write red brown, or if you write stays same, no problem. And here bromine water, changes from brown to colorless. Okay, so you need to write it down. uh, Next one, draw a circle on the diagram to show one repeat unit. I taught you earlier this one, that this is an addition polymer because it is solely made of carbon chain. This is how we can identify easily. So look at this. Every two carbon will make one unit. So this is one part, this is another part. So simply what will you do, you are asked to draw, give the structure and the name of the monomer. So simple way, just give a double bond. So how the structure will be, see, if I draw, then it will be like this. Okay, wait a second. um, so we will have the structure of the monomer. So it will have C double bond C, and here we need to make a line in this way, one line, in this way another line, in this way another line. This is another line. Okay, fine. Then you will just write the substances. So it is C2H5. We can write what can we write? We can write C2H5. We can write here C2H5, and this one C2H5, and here it's okay. Actually, I have taken a very less space. This is hydrogen. This one is hydrogen. This one is hydrogen. Actually, this C should be here. C2H5. You can make it a bit bigger. Okay. So name. What will be the name? Okay. What will be the name? So you are asked to show one circle to show one repeat unit. So already I have shown, but you have to do a circle. So let us see how we can do this. So one repeat unit, I missed the, sorry. Um, I missed, so this is one repeat unit. This is one repeat unit. You have to circle like this. This has been too big. Repeat unit of this polymer we have drawn. Okay, so come to the name. So this is simply 1, 2, 3, 4, 4 carbon containing, and double bond is in the first carbon. So but1 in, or you can also write butene, right? You can write here but1 in. I would prefer but1 in. If you write butene, then it is also accepted. Okay, so let us proceed. give the structure of an isomer of the alkane in E2. So structure of an isomer. So if I have drawn already but 1 in, so you can draw but 2 in, right? But 2 in, and I hope you know how to draw this one. Okay, come to this question. Question number 5. Question number 5. Question number 5, you see, what is the name of the ore of aluminium? Thank you very much for your feedback. What is the name of the ore of aluminium which consists mainly of aluminium oxide? So this is bauxite, right? You know the name. So I'm writing bauxite. We have around 10 minutes left for today's class. So let us see how many questions we can discuss. Name this substance. So this is graphite, right? Okay. Next one, aluminum oxide is dissolved in molten cryolite. What are the reasons? So there are 4 reasons I taught you. The first one is to reduce the melting point of alumina, to reduce the melting point aluminum oxide. This is the first one. What is the second one? To increase the conductivity. So this is the second one, and they are asking for 2 only, so we are writing 2, but you can write saves energy, then seems reduces cost, okay, lower operating temperature. So many things can be written. Okay, correct. Next one, write an equation for the reaction at the electrodes in electrolysis. So their oxide will turn into oxygen, and it will lose 4 electrons. So this is the oxidation, and the next one is reduction. So I have written the reactions here, so you see. If you have doubt, tell me. I have written the balanced ionic equations here. Come to this one. This is the blast furnace, which is used to extract iron. So look at this. Place the elements aluminum, carbon, and iron in order. So what is the order? So these elements, aluminum, carbon, and iron, in order of the reactivity, with the least reactive element first. So what is the least reactive one? The position of iron is at the lowest here in the reactivity series, right? So iron is the least reactive, then carbon, then aluminum. Okay. Now you know that metals which are below carbon in the reactivity series, their compounds will react with carbon. That means carbon will react with the compounds of the elements which are less reactive than carbon. So carbon can definitely react with oxides of iron, but carbon cannot react with oxides of aluminum. Carbon cannot reduce aluminum oxide, whereas carbon can reduce iron oxide. So carbon reduction method can be applied for iron extraction. Carbon reduction method can be applied for iron reduction, but this carbon reduction method cannot be applied for aluminum extraction, because aluminum is more reactive than iron. So I have written the answer here. Carbon can reduce iron oxide, whereas carbon cannot reduce aluminum oxide to aluminum. The reason is the reactivity, okay, which is already explained. Okay, can we proceed to the next one then? Okay, this line is coming. Okay. What is the name of the ore of iron which consists mainly of iron 3 oxide? This is hematite. This is what? Hematite. You know this, right? The next one, the complete combustion of coke. I have written the reactions for so that I can look at this. The complete combustion of coke, carbon plus oxygen, carbon dioxide. The production of carbon monoxide from carbon dioxide. So carbon dioxide plus carbon in the middle of the furnace, carbon dioxide, when carbon dioxide goes up and carbon falls down, they react in the middle of the furnace to produce carbon monoxide. So this is the balanced equation. Um, uh, Next one, reduction of iron oxide. You know that carbon monoxide is the main reducing agent. So carbon monoxide reacts with iron oxide to produce iron and carbon dioxide. Okay. Next, the formation of slag. So calcium oxide plus silica will form calcium silicate. So CSiO3. Okay. The next question. Come to the next question. A student is told to produce the maximum amount of copper from a mixture of copper and copper 2 carbonate. The student adds the mixture to an excess of dilute sulfuric acid in a beaker and stirs the mixture with a glass rod. The copper 2 carbonate reacts with the sulfuric acid, forming a solution of copper 2 sulfate, but the copper does not react with sulfuric acid. Okay, you know that metals which are below hydrogen in the reactivity series will not react with acid. So copper will not react with acid. So when you add sulfuric acid, copper carbonate will react, copper will not react. So by this reaction, copper carbonate will form copper sulfate, right? So copper will remain as an insoluble substance, and unreacted copper can be removed from the mixture by filtration easily. Look at this. Describe two things that the student would observe when the mixture is added to dilute sulfuric acid. So what are the observation? One is a blue solution is formed because copper carbonate is a green solid and copper is a brown solid, right? So what will you observe? A blue solution. You have to write two observation only. A blue solution forms. This is the observation. And what could be the other observation? Other observation could be effervescence, right? Other observation could be effervescence. Next one, describe how the student can produce pure dry copper from the mixture of copper and copper 2 sulfate. So I have written by filtration, copper is separated from the mixture as a residue. This is washed with distilled water. We need to wash it with distilled water because some copper sulfate crystals, some copper sulfate solution can be present with copper. If you dry it simply, water will be evaporated and copper sulfate crystal will be found with copper. So it is necessary to wash the copper so that no copper sulfate is left. Then copper is dried. Then copper is dried on the filter paper. So then copper is dried on the filter paper. Okay. Next one, describe what the student would observe. Look at the question. Blue precipitate would be observed because you know that sodium hydroxide is added simply to identify the metal ion present, and here copper ion is present. So copper ion will react with sodium hydroxide to form copper hydroxide, which the precipitate is blue, and I have written this equation here. Next one, uh, after separating the copper 2 hydroxide from the mixture, the copper 2 hydroxide is heated strongly. The copper 2 hydroxide decomposes into copper 2 oxide and steam. So write an equation for the decomposition of copper 2 hydroxide. So this is the decomposition of copper 2 hydroxide as you are asked to write the state symbols. So you have to write it down. So solid, solid, and then it will turn into gas, right? So you are asked name a non-metallic element. Any element which is more reactive than copper would replace copper from its oxide, and we will get copper. So we can choose hydrogen or carbon, any one. These are the two non-metallic elements which are more reactive than copper. So definitely they will replace copper from its oxide. Next one, state the conditions required for this reaction. 7a. So you know that this is fermentation. By fermentation, we are producing alcohol, ethanol from glucose, right? So what are the two conditions? We need to use yeast, and the condition should be anaerobic in absence of air. So we can write anaerobic. Anaerobic. Okay. Next one, calculate the number of moles of glucose in 30 grams. So first I have found the MR of glucose. Then from MR of glucose, I have found the number of moles. Mass by MR will give you number of moles. So this is 0.167. Then calculate the maximum mass of ethanol that could be obtained from 30 gram of glucose. So the ratio from the equation is 1:2. Number of moles of the ethanol will be 0.334. MR of this one is 46. So mass of ethanol will be mass, number of moles multiplied MR, so 15.364. Similar sort of calculation here for carbon dioxide. So we have calculated 8.016. Ethanol can also be manufactured from ethene. Name the raw material which is the source of ethene. So see this calculation. If you have any doubt, you can tell me. So crude oil or petroleum is the source. At any moment, class can be over because we have less than a minute left. So thank you for joining.